Today we will discuss psychrometry chart and what is the psychrometry chart, how we can draw the psychrometry chart, and how we can learn the various types of the line drawn on the psychrometry chart. Firstly, what is the psychrometry chart? It is a graphical representation of the various thermodynamics properties of the moist air, and psychrometry chart is very useful for finding out the properties of air which are required in the field of air conditioning, and it eliminates lot of calculations. And there is slight variation in the chart prepared by different air conditioning manufacturers, but basically they are all alike. The psychrometry chart is normally drawn from standard atmospheric pressure of 760 mm of mercury or 1.01325 bar. So psychrometry chart, it has a number of lines. So firstly we discuss dry bulb temperature line. It is a saturation curve, and dry bulb temperature is taken as abscissa and specific humidity is taken as ordinate. So on ordinate here is the specific humidity, and at abscissa is the dry bulb temperature. So dry bulb temperature line are on the abscissa and drawn parallel to the ordinate, and these are uniformly spaced. So these are vertical lines on the abscissa, and they have the equally spaced between each line, and temperature range of these line on psychrometric chart is from -6 degree to 45 degree with a difference of every 5 degree and drawn up to saturation curve. So this is the temperature range for dry bulb temperature lines. And second line is wet bulb temperature line. So wet bulb temperature lines, these are the inclined straight lines, and these are non-uniformly spaced, run downward from the saturation curve to the right at an angle of 30 degree to the horizontal. So these are the wet bulb temperature line. Sometime at any point on the saturation curve, dry bulb temperature and wet bulb temperature are equal, as we can see here. So here is the dry bulb temperature is 5 degree and wet bulb temperature is also 5 degree, and at this point 15 degrees Celsius is wet bulb temperature and 15 degrees Celsius is dry bulb temperature, and here 25 and 25 both dry bulb and wet bulb temperature, these are 25 degrees Celsius. So these are some points at which both the temperatures are equal. Next is the dew point temperature line. Dew point temperature lines, these are the horizontal lines and parallel to the abscissa and non-uniformly spaced. As we can see, horizontal lines parallel to abscissa and non-uniformly spaced. At some points on the saturation curve, dBT dry bulb temperature and dPT, this is dew point temperature, these are equal. So these red line shows the dew point temperature line, and these are non-uniformly spaced. Next is specific humidity line. These lines are also known as moisture content lines. The specific humidity or moisture content lines, these are horizontal lines parallel to the abscissa, and these are uniformly spaced. So these black lines on the diagram, they shows the specific humidity or moisture line, and moisture content range of these lines on psychrometric chart is from 0 to 30 gram per kg of dry air, or from 0 to 0.030 kg per kg of dry air. So this is the range of the moisture content. As we can see here, it varies from 0 to 30. So next line in psychrometric chart, that is relative humidity line. The relative humidity lines, these are the curved lines, and these lines follow the saturation curve. So as we can see, these are the curved lines and follow the saturation curves along the toe. So these are the curved lines as like saturation curve. These lines are drawn with 10%, 20%, 30% and up to 100%. The saturation curve represents 100% relative humidity. So these are the values of relative humidity. Here the curved lines, it shows the relative humidity 20%. Here it is 40%, 60%, 80%, and this is the line of saturation curve. So this saturation curve, it represents the 100% relative humidity. Next line is the enthalpy or total heat line. The enthalpy or total heat lines, these are inclined straight lines. These are inclined straight lines, and these are uniformly spaced, and these lines are parallel to the wet bulb temperature lines and drawn up the saturation curve. So as we can see, heat lines, inclined straight lines, uniformly spaced and parallel to WBT lines, and goes up to saturation curves, and some of these lines coincide with, as we can see the wet bulb temperature line, these are also inclined line, and enthalpy or total heat line, these are also inclined line. So some lines are coincide with these WT lines, and these goes beyond the saturation curve. Total enthalpy is given on the scale above the saturation curve in kilojoule per kg of dry air, and the values of the enthalpy or total enthalpy is given on the scale that is above the saturation curve. So this is the scale on which we can read enthalpy. This scale is used to read the value of the enthalpy. Next is specific volume lines. Specific volume lines, these are the inclined straight lines at an angle of 60 degree with the horizontal uniformly spaced, and these lines are drawn up to the saturation curve. So these are the specific volume line, and the value of the volume lines are given at the base of the chart abscissa in meter cube per kg of the dry air. And the last one is the vapor pressure line. The vapor pressure lines, these are horizontal and uniformly spaced line, and these are not drawn in the main chart. As we can say, horizontal, uniformly spaced, not drawn in the main chart. The scale showing vapor pressure in mm of mercury is given on the extreme left of the chart. So this is the scale which indicate the vapor pressure line, and on psychrometry chart the various line indicate various psychrometry terms showing the condition of air, as if dry valve or wet valve temperature are known, the relative humidity can be determined. If dry valve temperature and relative humidity are known, the wet valve temperature can be found. If wet valve temperature and relative humidity are known, the dry valve temperature can be read from the chart. And if wet valve temperature and dry valve temperature are known, the dew point temperature can be found. And if wet valve and relative humidity are known, dew point can be read from the chart. If dry valve and relative humidity are known, dew point can be found. So today we discussed, today we have learnt about the psychrometry chart, various types of the lines of the psychrometry chart, and how we can draw and how we can learn the psychrometry chart. To get more videos on mechanical engineering topics, subscribe Anuniverse 22. You may like its Facebook page www.facebook.com Anuniverse22. You share this video among your friends and students. You share this video also on social medias, Facebook, Google+, Twitter, LinkedIn. Give your suggestions if required. You can ask your queries by commenting. Thank you. Have a nice day.